When you have a limit comparison test, or you want to use a limit comparison test, usually you use a geometric or a p-series to compare it to. In this case, I'm going to use a p-series. I'm going to compare it to, excuse me, my pen's not writing, 1 over n squared. According to p-series, this converges. So when you do your comparison, what you end up doing is you take the limit as n goes to infinity. My pen is not writing real neat, sorry about that. And you do 1 over what is given to you, 3n squared minus 4n plus 5 in this case. And you would put it over 1 over n squared. That is the same math that I like to call keep, change, flip. But how you simplify that, you take the limit, that is a limit, 1 over 3n squared minus 4n plus 5 times n squared over 1. When you take the limit to infinity, this would be your leading coefficient over leading coefficient, which is 1/3. So because you get a number, that is your L. That means whatever the p-series does, which is converges, or whatever the one you compared it to does, since this one converges, they both do the same thing. So this series converges. Since the first, you got an L, since the p-series converged, that means the whole series converges. And what you need to do is make sure that you prove the first one converges, and then you get a number, and then that means the whole thing converges. This third example is a little bit trickier. It is the sine of 1 over n. And so this one, we are also going to use a comparison, this limit comparison test to do it. We are going to compare it to 1 over n. And that's n equals 1 to infinity. Now, this one is a special name. If you've not learned it already, this is actually called the harmonic. It can be solved very different ways to know that it diverges. One of the easiest one is by p-series, and it diverges by p-series because p is equal to 1, and that means it diverges. However, when you go to compare this, it looks like something is wrong, or you don't know what to do with it. So let's write it out and see what I can help you with. You end up with the sine of 1 over n over 1 over n. And you're kind of like, I'm not sure about this. Well, if we take a side note and go over to whenever we learned L'Hopital's, we learned that the sine of x over x, when you take the limit of that, and of x to infinity, would be 1. That's one of the things we learned by L'Hopital's. You take the derivative of the top and the derivative of the bottom. Well, when we apply that to this one, you just do a substitution and you realize that x is 1 over n, this x is also 1 over n, and the x here works just the same if it's this one. So when I take the limit here at this point, I get 1. Because I get 1, that means they do the same thing. So this series, because the one I compared it to diverges, that means this series diverges. by limit comparison test. So that is it with limit comparison. I find this to be one of the nicer ones because usually you can do compare it to a p-series or something really easy.